Okay, this is question 2.35 from the CR, trying to figure out how a runner is going to complete the 10,000 meter run in less than 30 minutes. So basically it says he or she runs a constant speed for 27 minutes, but there's still 1,100 meters to go. So your delta x is 1,100 meters. He has to finish that he or she in 3 minutes. The runner must then accelerate at 0.15 meters per second squared for how many seconds in order to achieve the desired time. So delta x equals v initial t plus 1/2 at squared. V initial you're going to get from the fact that the runner covered 8,900 meters in 27 minutes. That was what was given in the problem. So I'm going to pause this and calculate this with a calculator. Give me a second. Okay, where was I? Okay, so that initial speed was 5.49. That's going to be important. I'm going to go to the next slide here. Whoops, maybe I'm not. How do I do that? All right, I'll clear the slide. Right. So V initial. My pen has stopped working. Or my iPad has stopped working. V initial is 5.49 meters per second. Now, you're not going to like my solution here because it's really complicated, and I probably won't give this to you, but see if you can follow along. So the delta x that has to be covered delta x that has to be covered is 1,100 meters. There's going to be two parts to it, and this is what's confusing about the problem. The first part, we'll call it delta x1, is that initial acceleration that they're asking for. How long do you have to accelerate for 0.15 meters per second squared, and then maintain that speed to finish in under 30 minutes. So what that's going to look like is delta x1, I'm going to call it, is v initial 1 t plus 1/2 a t squared, and that a is the 0.15 meters per second squared. The second part of that, after you're done accelerating and finishing the race at a faster velocity, I'm going to call that v naught 2 times t, and what I should do is call this t2 and this t1 and t1. That t1 is what we're looking for. And what you need to know is delta x1 plus delta x2 has to equal what's left in the race, which is 1,100 meters. I told you you're not going to like this. It's complicated. So we know v initial 1 is 5.49, so we'll be able to plug that in there. We know v initial 2 is going to equal v initial 1 plus that acceleration times t1. So however long you're accelerating at that 0.15, that'll tell you v2. Now we got to put these together. So these two we're going to sum right here. So you get v initial 1 t1 plus 1/2 a t1 squared plus delta x2, which is v initial 2, but I just said it was equal to that, is going to be v initial 1 plus a t1. That's all going to get multiplied by t2. But we know what t2 is. In order to finish the race in 3 minutes, which is 180 seconds, t2 is going to be 180 minus t1. So that's what we're going to plug in for t2, 180 minus t1. Sorry about that chicken scratch there. So long story short, when I put in all of this, Oh, and by the way, what does this have to equal? 1,100 meters. So long story short, when I plug in all of the numbers, you're going to get something that looks like this, and you guys can check my work, but it's going to be 0.075 t1 squared minus 27t plus 110.8 equals 0. When you solve the quadratic, you get t1 is equal to 4.1 something seconds, but it rounds up to 4.2 seconds, which is your answer. I won't give you this on a test.